Good afternoon, everyone. Today we're going to present the next-gen packet cable multimedia project that we are working at Comcast. And I'll be co-presenting with that. With me, I have Kasim Inan from my team, as well as Mohammad Chowdhury. So what we'll cover is what is packet cable multimedia, what does PCMM stands for, right? And what is it? Why we picked Open Daylight. We'll also cover some of the key components of our next-gen PCMM product. We'll go over the architecture and we'll demo the two applications that we have implemented, telephony and in-browser notification, as well as we'll share some of the projections that we are shooting for scaling and performance. And last but not least, we'll provide the details about the new features that we have implemented and defects that will be contributing to the Open Daylight community. PCMM, Packet Cable Multimedia, is a specification managed by Cable Labs, which in short provides quality of service for voice customers. Primarily, enabling costs for voice is the focus for PCMM. However, we also leverage Packet Cable Multimedia to communicate with our customers using in-browser notifications. So that is the reason why we have implemented two applications. One is telephony and the other one is in-browser notification. So the reason why, when we're researching about implementing packet cable multimedia in-house, we've gone through a couple other technologies and evaluated, and we ended up with Open Daylight. The primary reason for that is the packet cable multimedia plugin that Open Daylight offers. And when we were looking into that, we came across all the other goodies that Open Daylight offers, which is model-driven service abstraction layer, MDSL, ease of adaptation, Yang modeling, and advanced message queuing protocols. So that basically leveraged us to use Open Daylight for this project. Some of the key components that we have for our next-gen PCMM is the telephony and browser notification. And we also have to implement a couple other auxiliary applications, which is Discovery Agent and Operational Support, which we'll share more when we'll demo the telephony and browser notifications. So this is what our architecture looked like. As Neil was mentioning this morning during the keynote, it's going to provide quality of service. So we have two applications, talking to the application manager, getting the request to in-browser notification to the ODL controller of to our CMTSs. So we'll provide you the demo for telephony application, and Kasim from my team will share more insights, how we leverage this application and how we are using ODL. So,
Thank you, Samir. So, as seen in this diagram, we have created a telephony application that handles the incoming requests, diameter requests from the voice application manager, which are then tunneled to the ODL PCMM controller over the REST-conf interface. We have expanded existing Yang model and made some modifications to the PCMM, made modifications and additions to the ODL PCMM plugin to meet our network needs. Requests once received by the ODL PCMM plugin are converted into policy rules and transferred over PCMM COPS PR interface to the cable modem termination system that applies the actual rule for a particular call. In this slide, you can see the actual message flow between various components in our network and the PCMM server that we have created. The important thing is the middle two blue boxes that upon receiving the diameter authorization and authentication request, generate and send the gate set request over to the cable modem termination system, CMTS, which creates the service flow for a particular call. And the second important part is the session termination request, once received from the PCSCF, triggers the generation of gate delete messages, which is sent over to CMTS to clear the established service flow. In this slide, we will go over pre-recorded live demo we had in our. Let me just start this first. I can barely see the. All right. So this is a pre-recorded live demo we had in our Comcast lab using actual physical network elements and phones. Following is complete diagram of the network components involved and the events as they happen while making the call and initiating the actual quality of service and termination also. These are the actual EMTA call party, calling party elements or SIP clients that our actual phones are connected to, which initiate the actual SIP init messages. This is our Cisco 10K CMTS, which establishes the service flow. And this is the PCSCF network element, ACME 9200. Here you can see one of our team members dialing in a number to a second phone that's also in our network. We have removed the audio, but soon you will see the actual red blinking light that indicates the incoming call. And he'll just answer the call there. In the background, on the PCMM server, you will see the logs that the actual AR was generated by the PCSCF, which triggers 2 gate set requests, one upstream, one downstream to the CMTS with all its parameters. And here you can see upon successfully acknowledging, CMTS acknowledging the request, the AAA is sent, and at the actual CMTS, you can see the gates, the quality of service gates established at the CMTS for that particular call. Ending the call triggers STR requests, which triggers gate delete, 2 gate delete requests. And here you can see that all the gates are being cleared upon ending the call. These are following our 2 drawings of the 2 additional scenarios we are actually, we have also implemented. One is call on hold and the 3-way calling. All the scenarios are currently working and lists all the network components and the events that occur at each element. With this, I'll hand it over to Mohammad for the IBN in-browser application.
Thank you, Kasim. Yep, thank you, Samir. So I guess I have to go back to, all right. So this was the original diagram we were looking at, and we're going to talk about IBN, which is our in-browser notification platform. In this case, you can see that we have a third-party application that's we are referring as application manager, which is initiating the request. And when you send the request, you need at minimum the subscriber IP that you would like to target, to send the notification. So that goes by the REST API, and your IBN component or app will basically convert that message, sending it back to the ODL layer, and it will leverage the YANG and MDSL, finally converting the message to COPS so that it can deliver to CMTS, which is a hub where the cable modem is connected, and it will be relayed to the subscriber to see the notification. So next, let's take a look at the message flow. So this is a typical message flow where it initiates a REST API request from a third-party application, and you can customize it the way you need, but you need at minimum the IP address where you want to send it. Eventually, it will go through the DOCSIS layer and it will be delivered as HTTP message. When the user acknowledges the notification, it will basically send a response back, eventually sending a response back all the way to the requester application with a response to the success. Now we're going to watch a live demo, which is pre-recorded, of course. And let me find the play button. Is it? I can't even see it.
It's visible on the big screen.
It's, maybe you should look here. All right, thank you. So we're gonna just see the demo from our QA lab. This is our QA lab setup for end-to-end flow. As I said, it's gonna be starting from the messaging manager, the initiator of the request, ending up with the CPE or customer premise equipment in this case, which is a PC. Here you are seeing the setup where our IP subnets and the CMTS that we are testing is in the network. We found the IP subnet which will be used for routing purpose. Here the CMTS is connected from the log. We are verifying there is currently no active gates or no request in place. This is the configuration for the REST API for the create session, which will fire the session request for API. Here you are saying the definition of templates. This is the subscriber IP we are targeting, which we will be sending the notification. These are some REST API config files that was being created in our lab. Here you are seeing some of the creation time and the token IDs and some of the dates and all of this nice stuff for that. Here we are seeing the actual message, in fact, with the classifier in the CMTS. As you can see that it actually got established here, and this is also a message response from the CMTS confirming that the request was a success with the 200 message. Here you are seeing the gate and gate ID from the CMTS, and this is the COPS message where traffic has been classified for that particular device. Here you are seeing the definition of the template which will be showed to the user, end user in this case, and the life cycle or start and end time of that notification. So this is a sample of the notification that we are using. In this case, we are sending a copyright alert for DRM violations on the customer device. And we have also done this for different use cases where this is where we are sending a threshold notification for high users that you are reaching out of your cap. And this is all electronic and you can customize all of this in advance. Here we are looking at the termination of the request. So the session will be now deleted, and basically it's gonna trigger a get delete request which will eventually remove the notification unless the user acknowledges that in advance. So we are looking at the delete gate request, and now that we are verifying no more gate is there, it's all gone, couldn't be found anymore. And this is coming from the log, and that was a demo. Now let's take a look on the scaling and capacity. So right now we are testing this in our lab end to end. The current challenge is we are targeting to get these numbers achieved. So our projection is at minimum we would like to get 600 transactions per request for the voice applications, which is our RX, diameter RX in this case. And for the IBN, we are shooting for 50 transactions per second that we are right now projecting. These are the number of features, defects, and enhancements that we have scheduled for upcoming Carbon release. These are all fixed and verified in our QA lab to be working. The first one is a REST API interface where we have introduced the REST API hooks to consume any external application to send a request through IBN. The second one, basically what we have fixed is how to activate the classifier information when you send the traffic to upstream. The rest, you mostly see the voice features, which also includes call on hold, which is you can put somebody in a hold and make another call, three-way call, which is a conference call, where you can deliver the course. And we have also implemented MGPI, which is a concept where you can, for commercial customers, you can group more than one call, and using the same service flow or pipe, you can deliver more. So we use it for our business class voice. And also, obviously, if you have an emergency call, that call needs to be prioritized. So there is in the CMTS, you can actually send the markings, what we have fixed. And next one, the video call is what we have done is you can actually watch somebody in real time if you have a video capable phone. Next one is V6 support, which is we have end-to-end V6 on the data plane. You can make a call through native V6. The last one is where we have enhanced the COPS connectivity on the CMTS in the event when a CMTS loses its connection, or if you have connection pool management, we address that automatically by the system. With that, I'm going to hand it over to Samir Patel.
Thanks, Mohammad. So these are all the features that we'll be contributing, as Mohammad pointed out, and it will be available in the carbon release of Open Daylight. Lastly, this project would have not been possible without the support of folks from Cable Labs, Applied Broadband, Comcast, Linux Foundation, and ODL. Especially big shout outs to Kevin, Karthik, Ryan, Brian, and Steven from Cable Labs. Our partners in crime, Applied Broadband, Jason, Jeff Pettigrew, who we have in the audience, Dr. David Early, and John Thompson. Thank you for the guidance and support to the Comcast peers, Chris Luke, Che and Jason, as well as when we first tried to implement integrate ODL with the diameter library, we came across a lot of issues. So thanks for the support from Linux Foundation, from Phil, Casey, Colin, and Robert, as well as the great guidance from ODL community, which is Neil and Pankaj. So that's our presentation, and looking forward for the collaborations in near future. Thank you.
Don't forget to mention.
Do you have any questions? All right.
I'm just wondering, what else is running on this network, or is it a network just for telephony? Or?
That's a very good question. So currently, we have implemented two applications. One is telephony and then browser notification. We are evaluating few more applications, building a business case that we can run on top of the ODL controller. One example I can give you here is WebRTC. So we can certainly integrate WebRTC with the controller, as well as other applications specific to a cable modem terminating system, the CMTSs. We can certainly implement. We are working towards implementing those as well.
And then just one other question.
Sure.
Your Open Daylight installation, is that like a multi-node installation of Open Daylight, or where do you use?
Yes, so we have just completed implementing this product, so it will be definitely multi-node installation, and we are shooting for market trial next quarter. Yeah. And one thing I want to note, we do have goodies for this project as part of that. So we have t-shirts and laptop stickers for all you guys, so please collect that for your exit. Thank you.
Thank you.
Good afternoon, everyone. Today we're going to present the next-gen packet cable multimedia project that we are working at Comcast. And I'll be co-presenting with that. With me, I have Kasim Inan from my team, as well as Mohammad Chowdhury. So what we'll cover is what is packet cable multimedia, what does PCMM stands for, right? And what is it? Why we picked Open Daylight. We'll also cover some of the key components of our next-gen PCMM product. We'll go over the architecture, and we'll demo the two applications that we have implemented, telephony and in-browser notification, as well as we'll share some of the notifications. So that is the reason why we have implemented two applications. One is telephony, and the other one is in-browser notification. So the reason why, when we're researching about implementing packet cable multimedia in-house, we've got projections that we're shooting for scaling and performance. And last but not least, we'll provide the details about the new features that we have implemented and defects that will be contributing to the OpenTelex community. PCMM, packet cable multimedia, is a specification managed by Cable Labs, which in short provides quality of service for voice customers. Primarily, enabling costs for voice is the focus for PCMM. However, we also leverage packet cable multimedia to communicate with our customers using in-browser